In this video, we're going to be doing a problem set for AP Physics 1. What states of matter are considered fluids and why? The answer is liquids and gases. What's the definition of a fluid? A fluid is any substance that cannot resist shear stress and therefore flows to take the shape of its container. Liquids and gases, we can define these. So a liquid is going to flow and take the shape of the container, which means you have a fixed volume. And no fixed shape. For gases, they flow and expand to fill the entire container. Which means you have no fixed shape or volume. Why are solids not included? Because solids resist deformation and they keep their shape. So fluids, they deform continuously under even a small force. And later, this is where we're going to get pressure from. A block of mass with a width of W, height h, and a thickness of t has a mass of MO distributed uniformly throughout its volume. The block is then broken into two pieces, A and B, as shown. 3 students make the following statements. They both have the same density, it's the same material. The density is the mass divided by the volume, and the volume of V is smaller since the mass is uniform and the volume is the denominator. The density is larger for B. And lastly, the density of piece A is larger than the density of piece B. Since it is larger, thus it has more mass. So again, what we have is these blocks are the same, and the block was one block, and then the mass is distributed uniformly, so then it's cut into 2 pieces. So P, or this symbol, is rho is equal to M over V. So if you solve for M is proportional to V, and since we know that the material is uniform, that means that mass will be proportional to V. Therefore, we know that this is going to be constant throughout. So AJ's claim that they both have the same density is going to be true. That's because the blocks are the same material. You have a uniform distribution. And also your density does not depend on size. Ben says that if B has a smaller volume, so that means that the density is larger. That's wrong. A smaller volume does not mean larger density. VB is smaller, but also MB is proportionately smaller. So they still have the same ratio. Now, what about Chithra? So what Chithra is claiming is that the density of A is larger than the density of B since A is larger. So she's saying that A is larger, more mass would mean higher density. But density is not about total mass. Our formula is rho over m over v. So it's about mass per volume, not total mass per volume. So that's why AJ is your only one that is correct. A rectangular block is at rest on the table. 3 faces of the block are labeled A, B, and C. Face A has dimensions 3 centimeters by 4 centimeters. Face B has dimensions 2 centimeters by 3 centimeters. Face C has dimensions 2 centimeters by 4 centimeters. Rank the pressure exerted by the block on the table when it is resting on each labeled face. Okay, so we can calculate what the faces of each are by finding the area. So for A, we have 3 by 4, which is 12 centimeters squared. For B, we have 2 by 3, which is 6 centimeters squared. And for C, you have 2 by 4, which is 8 centimeters squared. So our pressure formula is pressure is equal to force over the area. So what here stays constant? Our block stays constant. When you have the same block, that means that you have the same weight, and weight is equal to mg. So that means that your force is gonna be constant. So P is proportional to 1 over A because this is an inverse relationship. So now we can see from this that if you have a small area, it's going to mean you have the opposite direction of pressure. So that means that you're going to have a large pressure. Also, if you have a small pressure, or let's just say a large area, that's going to be a small pressure. They're going to be opposite of one another. So now we can rank. So face B has a 6 centimeters squared. So its area is going to be the smallest. When you have small area, you have large pressure. So that means that face B has high pressure. 8 is in the middle. That is a middle size area. So that's going to be a middle size pressure. And we have the largest area, which is 12. So that means if you have a very large area, you have small pressure. So our ranking is going to be B is greater than C is greater than A in terms of ranking from greatest to smallest of pressure. So let's do question 5. In what direction does pressure act in a fluid at a specific point? So pressure acts equally in all directions at a given point. That's because at any given point in the fluid, your pressure is isotropic. That means that it's the same in all directions. It acts perpendicular. You could also say normal, 90 degrees to any surface. And this comes from our fluid particles in the mass colliding randomly. So our pressure is a scalar, and it acts equally in all of our directions. Let's do our next question. Air's density on a given day is 1.29 kilograms per meter squared. Imagine the classroom where you look at this data, and it is approximately a rectangular prism with dimensions of 3.5 by 4.0 by 2.5. Calculate the volume of the room in meters cubed and centimeters cubed. What is the mass of the air in the room? So volume is going to be equal to 3.5 times 4.0 times 2.5, which is 35.0 meters cubed. Now for the mass of your air, this is equal to rho, and that's m over v. We want to solve for m. M is equal to v times p. That's 1.29 times 35. So that's going to be 45.15 kilograms. Now, a block of wood floats in water with 2/3 of it submerged. The wood is then placed in oil and 9/10 of it is submerged. Find the density of the wood and the oil. So in this, you are going to have an equation set up where you have your pressure of your fluid times the V of the submerged object is equal to the pressure of the object, and the V of total. So this is gotten from M is equal to VP, and then you set them equal. Now, after this, you can rearrange this. V sub over V is equal to P object over P fluid. Now we have to calculate this 2 times, one for when you're in water and one for when you're in the oil. When you're in the water, it's 2 over 3 P W over 1,000. So that is equal to 667 kilograms per meters cubed. Now when you're in oil, this is 9 over 10 is equal to 667 over P oil. P oil is equal to 667 over 0.9. That's 741 kilograms per meters cubed. So P of the oil is 741 kilograms meters cubed, and P in the water is 667. So that was our 2/3 for water, and this was our 9/10 for oil. Find the approximate minimum mass needed for a spherical ball with a 40 centimeter radius to sink in a liquid density of 1,400 kilogram per meters cubed. So our condition for this is that our mass times gravity is equal to P fluid Vg. If you rearrange this and we solve for m is equal to P times V. Now, V of a sphere is equal to 4 over 3 pi radius cubed. So you want to plug that in. You can compute this here. This is going to be 4 pi, or we'll just do it here. Our m is equal to 1,400 times 4 over 3 pi 0.40, because you have to convert to meters. So that's 0.40 cubed. And if you plug that all in, you should get 375.2 kilograms. Okay, a large boat like the one shown above has a mass mb and can displace a maximum volume vb. The boat is floating in a water with density of P water and is being loaded with steel beams, each of density P steel and volume V steel. The boat owners want to be able to carry as many beams as possible. Derive an expression for the maximum number n of steel beams that can be loaded onto the boat without exceeding the maximum displaced volume in terms of the given quantities and physical constants as appropriate. You need to know what is our buoyant force. And that is the FB. Force that's buoyant is equal to the density of the water times the volume B and times G, your gravitational constant. And also, what is weight equal to? We know in general Fg is equal to weight, and that's usually mg, but here we are looking at our m total times g. So you have the mass of the boat plus np steel v steel times g. N is the number of steel beams without exceeding the maximum displaced volume. So that's why you incorporate that multiplication. So now you are going to take these two and you're going to set them equal to each other. So you have FB is equal to FG. Taking this side, and you're going to set that equal. So you're going to rewrite this. Rho water VBG is equal to MB plus NP steel V steel times G. You have G on both sides, so you can just cancel G out. And you have MB plus NP steel V steel. If you solve for N, Now what you have is NP steel, V steel. You want to divide both sides by V steel. And this is your answer. Now,